talking about logarithms, or just logs. So we're just going to prove that logs are just exponents by switching from exponential form to logarithmic form, or log form. And then we'll do some logs by hand. Also, we'll compute some with a calculator. And finally, we will observe how logs behave graphically. So the purpose of this video is just to get comfortable with logs, some names we use for some stuff. And yeah, okay, so I know on your calculator you've seen log before, but you're like, what is this thing even for? Am I ever going to use it? So starting off, when you see log written, just know that this thing is something that spits out exponents. It's what its job is, it's what it does all day. Yeah, so that's the first thing you should think of. When you see log, that thing is going to give me an exponent. Then there's two parts, two components to a log. There is the base, where I've indicated here as A in red, and then there's the argument, which I've indicated in blue as B. So notice how the log and the B are aligned with each other, and then the base, we just write it a little bit lower. That was just the basics of logs. Now we're going to go ahead and switch from exponential to log form and vice versa to get a better feel for this. Alright, so here we're going to go ahead and switch from exponential form to log form. Here I have something, here's an example of something that's in exponential form. 5 raised to the power of x is equal to 25. Now, if we wanted to switch this to log form, we know it's a log form because we see log appearing. The way we're going to do that is, notice that our 5, which is the base here, is going to become the base of the log. And then, remember we said that logs, their job is to spit out exponents. So this log is going to spit out the exponent that the base was carrying. And then this 25 is just going to take the place of our argument. So this would be exponential form, that would be log form. And this makes sense because what this is saying is 5 to what power is equal to 25, or 5 raised to what exponent is 25, and we said that the log already does that for us. It'll compute what exponent or what power 5 has to be raised to give us 25, and we know that that's 2, 5 squared would be 25, so if we input that in the calculator, it'll do that for us. So this is just switching from exponential to log form. Alright, so just in general, when you have an equation like this, something being raised to a power and that's equal to something, it's an exponential form right now. If you want to switch that to logarithmic form, it would look like that. So I'm just going to go ahead and write this on the side of the board as we continue if we ever need to switch from exponential to log form or vice versa. Okay, so I just listed out some examples for us to try. Start simple and then we'll get harder as we go. So let's start with this first one here. We see log written, so we know that the answer is going to be an exponent. That's what log spit out. What this is really saying is 2 to what power is equal to 4. And if we wanted to write this in exponential form, it would look like this. What this is really saying is 2 to what power is equal to 4. And we know that that's just 2, so 2 squared would be 4. So something like this, you don't really need to use a calculator for. Maybe later on we might need to do that, but stuff like this, we know stuff like this. So moving on over here, this is just going to, our answer is just going to be an exponent again, just like it was here. This 2 is actually the exponent here, so 2 squared would be 4. What this expression here is saying with the log is saying 3 to what power is equal to 27. And our answer is going to be the exponent here. So in this case it's 3. 3 cubed would be 27. Okay, moving right along here. What this is saying is 2 to what power is equal to 32. The base on the log is always the base when you switch to exponential. So this one you might not be so familiar with, but it's 5. So 2 to the 5th power is 32. Okay, moving on over here, what's different about this one is with these 3 examples, the base was indicated for us, but here we just see the argument, which is 100. So this is just a general note. when you see log without a base written, we're assuming it's a base 10. We're just automatically assuming that. So let me just go ahead and point that out in red, because that's very important. So now what this is saying is 10 to what power is equal to 100, right? And the log is going to take care of that for us. So we know that 10 squared would be 100. Okay, so these are some examples I've done, and then I'm going to have you guys try one. Alrighty, so why don't you guys go ahead and give this a shot to see if you're understanding what the whole log thing is saying. Okay, so this is in log form right now. I could switch to exponential if I wanted to. I'm going to write that out anyways. But it's good to know what this is really saying. It's saying 13 raised to what power would give me 169, and the log takes care of that. It's going to spit out the exponent that satisfies that. So just really quick, if I want to write this in exponential form, it would be 13 to what power is equal to 169. These two are saying the same thing. 13 squared would be 169, so the answer turns out to be 2. And let's go ahead and look at some more examples. Okay, so let's go ahead and try another example. The only thing that's different about this one is that we see the base, which is normal, we see the argument, but now the argument is carrying an exponent. So in the previous examples we've done, the argument has always had an exponent, it's just been 1. So it's really just insignificant, they didn't affect us this whole time. But now that we have an exponent, let's just go ahead and apply the exponent first before evaluating this log. So we'll get log of base 16, and then 4 squared would be 16. Okay, so what this is really saying is 16 to what power is 16 again? We could write that in exponential form if we'd like. 16 to what power is equal to 16 again? The only value that could make this possible is 1. So the answer turns out to be 1. But this is kind of like a special case. Whenever the base and the argument are the same, your answer is always going to be 1. So I'm just going to go ahead and add that to the side of the board because it's one of those special properties that you should know that will just save you some time. Okay, so moving right along. Here, the base is not indicated for us, so when the base is not indicated for us, we know that that's automatically a 10. So let me just emphasize on that because that's very important. So now here we have log base 10. The argument is 4, and now the exponent is 0. So let's just go ahead and apply that exponent and see what happens next. So this would be log base 10. Anything to the 0 power is 1. Okay, so now what this is saying is 10 to what power is 1? And let's go ahead and write that in exponential form if we'd like. 10 to what power is equal to 1? It's kind of referring back to this guy again, because the only way that raising 10 to a power to give us 1, that it would have to be 0. That's the only value that would make that true. So the answer turns out to be 0. So this is another special case. I'm going to go ahead and add it onto the side of the board. Is whenever you have log and your argument is 1, your answer is just always going to be 0. It does not matter what your base is. As long as your argument is 1, you will always get an answer of 0. Okay, so just doing another example here. Log base 2 and the argument is 1/16. So we've never had a fraction before, so let's go ahead and investigate that. So if we were to look at it as a fraction, what's really sticking out the most is this 16 here. We know 2 to the 4th power is 16, but this is the reciprocal of that. So if you recall the negative exponent laws, because we know 2 to the 4th power is equal to 16. But I want 1 over 16, so if I were to change this to a negative exponent, that would be equivalent to writing that on the bottom the positive exponent, and then 2 to the 4th power is 1/16, which is what I'm looking for. So 2 to the negative 1/4 power is 1/16. And if we want to write this in exponential form, what it's saying is 2 to what power is equal to 1/16. And we just saw that when we raised 2 to the negative 1/4 power, that was equal to 1/16. So the answer here would be -4. Okay, so pretty similar to the last example, we have a fraction inside the argument. So we kind of saw what happened with that. So, just to write this in exponential, just to get a feel of what this is really saying, it's saying 4 raised to what power would give me this argument, which is 1/64. So really the 64 is what's sticking out here. We know 4 to the 3rd power is 64, but we want 1/64, so we use the negative exponent laws. So if I were to do 4 to the negative 3rd power, that would be equivalent as 1/4 to the positive 3rd power. And we just saw that 4 cubed was 64, so then I get 1/64. So here I saw that when I raised 4 to the negative 3rd power, I got 1/64. So the answer would be -3. I hope I said 3 here. So yeah, the answer is -3.